Good morning, everybody. Welcome back. We are coming now to Chapter 8 of Unified Financial Analysis, and this is Part 3. There are significant differences between what we did so far and what comes in Part 3. So what we have to do is to explain some important terms so that we can distinguish what we did before and what we will do now. We know this picture. Meanwhile, we did everything regarding this blue part here. And now we are moving down here to the red part. What we did so far, we call input elements. Danke very much. Input elements is whatever goes into the computer. So whatever you did last Saturday was concerning input elements, getting contract data, market data, and counterparty data. These were the elements which we mainly were discussing here. Now these elements will then be taken and analyzed. And in the static analysis, as we do it now in Part 3, the analysis is almost automatic. Not completely, you have to have initial conditions, but the calculation, the engines are there, they just wait for the data. And turn it into first what we see here, financial events here. So that's the first step what these algorithms will do, meaning looking at the data and looking at what is going to happen to this contract over time under the given conditions of the risk factor. That's exactly what's doing. So it takes the contract, looks at the risk factors, and given that, it's clear what's going to happen to that contract. Of course, the risk factors are risky, so we don't know exactly how they are. So that's why the whole thing is not deterministic. But given the risk factors, it is deterministic. Yeah. So, and once we have the financial events, we create what we call the analysis elements. And that's the first thing we have to clearly distinguish, the input elements and the analysis elements. Sadly, in the world of finance, these things are often mixed up. You never know exactly where you are. Are you already in an analytical part, or is it some risk factor, rate, or something like that? So, but it's very sound to keep the things separate. As we had 5 input elements, there are 5 if you include the cost, but the cost we don't really discuss at the moment. But if we take those 5 input elements, interesting enough, there are 5 analysis elements. And the 5 analysis elements are liquidity, value, income, sensitivity, and risk. And you can go now to any financial report which you will find in the world. And they are all a combination of them. So far, it's possible that maybe tomorrow somebody comes with a 6th element. I'm not denying that, so that's possible. But today it's 5. So I've gone through thousands of reports, and it was always generated with these 5. Especially, we use the software in many banks, and these are the 5 they have, and they could produce any report which are there. So we have to distinguish between input element and analysis element. Here. Among the 5 analysis elements, there are 3 really very basic. So most finance people, they think in the 3 terms, which are value, income, and liquidity. So value is more or less the balance sheet, just as an abstraction, but it's also the value of an option. So on the balance sheet, there's nothing else than accumulate those values to total and show them. Yeah? Income is nothing else than the P&L, or the return, which you have on any instrument, and then liquidity. So here, these are the three main views. And then sensitivity is just the change of value given a risk factor change up here. So how sensitive are you to interest rates, to FX rates, to any of these elements up here? And then risk is nothing else than the fluctuation of either liquidity, value, or income by fluctuating market conditions. So that's how it has to be understood. And once you have these 5 elements, you can do anything you want. Very special in this system is to have liquidity, value, and income within the same framework. And this is a little bit special because liquidity is always the big problem for most people. So they don't have problem with value income. But then if it comes to liquidity, so how do you do that in bookkeeping, liquidity? Is somebody aware how you do that there? It's these cash flow statements, or Kapitalfluss in German, Kapitalfluss. But you might remember how that went when you learned it. So you take the balance sheet and you trick around, pull a few things out, the P&L, look at that, and deduct a few things, add a few things, and at the end you come to the liquidity. So, and there's always some dubiosity there whether it's really done right. Why? What are you doing if you do that? You look at the balance sheet, you're on this side. Then, basically, mentally, you go back to the event level. You ask yourself, which is liquidity effective? So what really does affect liquidity? So you take out those things which were not effective, you deduct them, so you come via this, but that's only mentally, because it's nowhere registered. Now, while you do the balance sheet, you know all that, but you throw all the information away. And then when you go to Kapitalflussrechnung or capital flow or liquidity statement, so then you somehow try to remember that from your mind. So you go back here and you come to the liquidity statement. That's how you're doing. So, and if you ask somebody who does like option pricing or something like that, and if you ask them, what's about liquidity, the people are fully puzzled. No clue, because the only thing the formula returns is, of course, value and return, value and income. So it's only here, and it's not right. But once we have set it up like this, so we have the financial event level, so that contains still the 2 sides, the liquidity side and the value side here. So the full information is basically here. And so that's why we have to go through this event level. Once we have this event level, we can still derive everything and fully consistent because it goes back to the same events. And we remember the events. It's pretty important. Something new also, a concept we have to be aware of. So in part 3, where we are now, we talk about static analysis. Part 4, which will then be the next, after chapter 13, I think, that will then be dynamic analysis. So we have to distinguish static and dynamic analysis. Static analysis, we did it already once, but I repeat it here, is taking the existing business and just keep it till it matures. So you run down the balance sheet, for example, if you're a bank. So like doing no new business. So you shrink. Now, would you really shrink in reality? Not exactly, because what you do, you put everything into cash. So it would run into a cash value. So this picture is not even fully realistic, but it's a good representation of what happens in static analysis. In static analysis, you look at the contracts until they mature, and you do not consider how they go on in the future. And you take a current risk factor situation, like for example here, it's a yield curve. So these instruments are interest rate sensitive. So you take the yield curve and you more or less discount these cash flows. So these are capital cash flows, but they're also interest cash flows. They will be discounted. And you get a value. And then if you go on, for example, you want to see a risk from these factors. This is what we do in this part now, in part 3. You take the volatility here, this volatility, and given the volatility, you can throw the dice. And you could, for example, simulate movements of the yield curve. So you would do that X times. Of course, I only show 3 times here. You would do that 1,000 times. Given volatility and correlation, you can do that. So you get a lot of future positions or change positions of yield curves. In each time, you value the above position, and you get something like a distribution. Distribution of an MPV, and the distribution of the MPV, do you know how you call that, how that is called in the market or in the risk management? What we have here? If you do that, so you take the position, you throw the dice of the market conditions, you revalue continuously, you finally get a distribution of your value. And how is that called? It's value at risk. I guess you have heard the term, huh? That's exactly what happens in value at risk. Now that's the technique. That's very dominant. It has come under fire, of course, quite a bit due to the crisis. But still, it's a tool which will stay there, but taken with a little bit more caution, with a little bit less faith. There has been a lot of blind faith in it. Or if we are in our systematics about types of analysis, so we do type 1 and type 2 analysis. So these are the yellow marked things. So that's what we do. And when we will go into dynamic analysis, it will be more here type 3 and 4. These will be the main analysis which we do then in part 4. So static analysis can also be called liquidation view, because that's the model which is behind static analysis. And we have to be aware that most what is called risk analysis is a static analysis or a liquidation view. Liquidation view means I do not want to continue my business. I just want to sell off. And once it's sold off, then I just have my cash box left at the end of the day. A liquidation view comes very much from the trading floor. Traders have very much a liquidation view. You know, they have a bank at night, so their portfolio you can consider like a small bank. And then they sell the bank at night, and they sleep well. And in the morning, they buy a new one. I mean, that's roughly speaking. So they have no connection with the thing. You could also kind of immorality. You know, it's just about money pushing out. But can you do the same if you have a bank, a real-life bank? You can't. So it's something which continues overnight, you know, and tomorrow there will be new business and so on. And of course, that should also trigger some different kind of thinking. So you are in the game. And we anyway should think about, is real liquidation view even possible? As a thought, it's possible. As a little model of behavior for a few people, it's possible. But imagine everybody wants to liquidate. So everybody's going to sell. So what will happen to value? So what happens to value of something nobody wants? Everybody wants to give. The same happens to apples and pears. If everybody wants to sell pears, nobody wants to buy them. So the value will drop to zero. And that happens to even financial assets. Actually, this is what happens in a crisis. Too many people trying to sell, you know, and the values drop drastically. But this thought experiment even shows that value cannot exist in a liquidation world. Value depends itself on going concern. If there's nobody there which believes in the future, which is going to buy what you sell, the world goes to zero. You can see that very well. I think you're old enough. You remember when the Iron Curtain came down, the Berlin Wall fell, so Eastern Germany came in. The Germans, the Eastern Germans, they were on a selling spree. They didn't believe in their own future. But there were a few then from the West who believed in it, so they picked it up, and they got good deals. But that's one of these extremes, So value itself is a going concern principle. There is another thought experiment which is very interesting if we talk about liquidation view. In liquidation view, if I go back here, we stay here. Time-wise, we are blocked here at T0. So we look at the portfolio from T0. And this dark here, yield curve is the yield curve at T0. And we stay at T0. So we have a time step of 0. There's no time step. We stay there. So how much is our rates going to change if the time step is 0? How much are market conditions going to change if time doesn't change? Not changing. So you see some contradiction, but it does not fully devalue static analysis. It still, as an experience for management, it still has value. But we should not overestimate it. And there are some industries where it doesn't make a lot of sense to do static analysis. For example, if you are in life insurance and all that thing, there it's almost a contradiction to do a value at risk on that. But of course, for the trader, it's a kind of valid. He, in his small world, he can sell any time. So for him, it's a kind of reality. But only as he is a small part of the whole, and if not everybody likes to do that. So, okay, but as a management tool, it's still valuable. But we shouldn't stop there. That's the message I want to give you. So real life, he figured out, is a going concern. Actually, in real life, almost everything is a flow. And the stock is almost like a little artificial thing. Okay, you could say the Rhine is a flow and the Lake of Constance or Lake of Zurich is a stock. But even that flows slowly. So reality is a flow. And this value view is a highly artificial thing. Which doesn't really exist in the core. Okay, but still, it's a good concept for management. So these are the 5 analytical elements. We have been discussing them already. So all the financial reports are, as of today, made up of these 5 elements. I could imagine that there would be a 6th element tomorrow. Who knows? Because I deduct that because already during my lifetime, 2 elements have come which were not there before. Which one of them would you consider are new elements? When I was a boy, they didn't exist there, or maybe only in some highly academic quarters, but nobody knew about it in the banks and so on. Anybody, I guess? No, liquidity. But liquidity was the most important, actually. It just got forgotten. For today, maybe for you, it's the new one. That was the oldest. No, it's sensitivity and risk. So there were only, bankers were generally in finance. You were considering 3 things: value, income, and liquidity. The balance sheet, the P&L, and the Kapitalflussrechnung, capital flow statement. So these were the 3 things. And newer measures are sensitivity. To do that, of course, you have to have higher mathematics. You have first derivations and stuff like that. And of course, that came only in, I would say, end of 70s, mid-70s, then it came. It was closely linked to option pricing, when we had options and we had deltas and all that stuff. So, and this type of analysis were then extended to other parts of the balance sheet. So that's, also with trading and all that. So we have the three main views are really income, value, and liquidity. These are the three things. And these are derivations of that. Actually, even already income is a derivation of value. So we really have two concepts. Income is the derivation against time. So income is the change of value over time. That's how you can see that here. So generally what you have are two streams, really, and you will see that then in RiskPro and also here in the book. So there are always two views. One is what we call the liquidity view, and the other one, we gave a little artificial name. We called it ZES, zero coupon equivalent sensitivities. Because once you have that, you can go between all the concepts. It's value and income and sensitivity, so they're all related. They are closely related. So what you really have inside the analytical world are two concepts from a strict analytical purpose. And all the rest is then derived. So once you have like the value, you have income. Or you could also say you have income and value is the integral of income, something like that. So these are closely related here. Okay. And we will come to that then. So these are the two views, and when we do the examples, you will see the two views always. Yeah. Then other important distinction we have to draw is between financial events and cash flows. Most people, you could go to hundreds, and I think almost everybody, you would say, okay, once we have all this input, so what will we do next? And invariably, if somebody is good in analytics, I think almost everybody will say cash flows. Everybody is quite eager to jump to the cash flows. So let's show me the cash flows. And that is a jump one too early. Because if you say cash flows, these people will invariably either go in this direction or that direction. If you are in cash flow, you only have, you can represent one or the other world. And of course, real cash flows you have anyway only here, and if you are in this world, it's a kind of sometimes artificial cash flows. We will understand that a little bit later. So then you have two parallel worlds which are not well connected. So what we need is really these financial events. That's the full information, or called also rock bottom of finance. So you can't get deeper. So these are the strings of finance or whatever, if the strings are the last things in physics. But here we have really a last thing. So it's much simpler than physics, by the way, because it's human-made. So we know how deep it's going. So what do we find on financial events? On financial events, we find what happens to the contract. Like, say, if it's a bond, you pay out principal, you get back interest, principal. So that's a simple event. But if it's a variable rate bond, so you pay out principal, you get out some interest, you maybe get another interest, so then you recalculate the interest, you go to the market, you check in what is the new condition, you plug it into the system, that's another event, but then that determines the next interest and so on. And of course the complex get more and more complex, and you get more and more such algorithms, which then relate to market conditions. And so each of this happening is called an event. So then that's the fullness of what you can get. So everything which has to be known must derive from that. And this you get on that line. And once you have that, we can go in any direction. So we are fully set here. Yeah, okay. So the event level contains all information that is possible in finance, and of course that has some preconditions, that the input must be rich. Okay, the event level can only be as good as our model is, but the model can be very good, because financial contract can be described. It's a finite set of rules. The contract, the market condition is something different, so you keep them separate. But the contract, the rules of the contract are. And then and then we have behavior. We said already last time, because some contracts rules are broken and fuzzy and so on. So there you have to have a model. But you need a model, and we have nothing better than a model. So that's the max we can get. Like if you model saving accounts, for example. It will always be imperfect, but without model you're worse. With your model you are better, but you're not perfect. So you come somewhere in the intermediate world. If once we have created the financial events, so then all contracts are equal. In the sense of a saving account can be looked at like exotic option. Of course, exotic options have many more different events than saving accounts. But where they overlap, so there they are even. If the underlying of an exotic option is an interest payment, that interest payment of the underlying has the same interpretation as an interest payment of a saving account. Of course, and there's a lot of non-overlapping stuff, so in this sense, it's not exactly the same. Yeah. So that is rock bottom of finance. And here may be a question. What are the events in option pricing? Actually, to really understand what happens in option pricing, the best way is to treat it in a Monte Carlo fashion. To run different parts and then go always to the payoff. Look at the condition, look at the payoff, discount it with those conditions, run another part. But of course, if you have Black-Scholes, then this is all hidden in that closed form formula. But you have a lot of possibilities actually in there. And treat it very elegantly. You don't really need to do a Monte Carlo because that wouldn't be very efficient in this case. So just to give you some feeling, that. But there the events are hidden a little bit. So that's why I take that example. But it's not different in reality. So here we have a list of the most important events. VD, for example, and you will see these events, I think next week, something like that, when you run the first calculations on every contract. So VD is inception of the contract. So when the contract really starts, it stands for value date, actually. And all contracts, somehow that appears in all contracts. Maturity date is when the contract stops. Like in a bond, it's the last date, but it's more complicated if you have annuities and all that stuff. But it applies for maturity contract types. Interest payments. So here that is in most contracts. Then capitalization, rate reset is a very important event. So where you go to market conditions, look at the conditions. So that applies for all variable rate maturities. Decrease, increase maturities, so decrease especially for all the amortizing instruments. Amortization, so that's with annuity special. That is determination of the contract. So when you break, you sell a contract at a certain time, or you stop a contract earlier than maturity date. OPM is the payment of an option exercise. PRP, prepayment of outstanding principal. So this is one which is related to behavior. So a prepayment function, that's a behavior function. Sale, and so on. So there are more, but it's a limited number. I think there are about 24, roughly, 24 events, which describe the richness of the financial world, which happen on the underlying and depending on the contract type. Events are linked to the timeline. It's just like reading a contract on the timeline. Another good comparison is what happens in the transaction system. The transaction system are the systems where the contracts are managed over time. So these systems also look every day something happening to the contract. Like, for example, it's a variable rate. It looks something happened to the contract, maybe no. But maybe tomorrow, oh, there is a rate reset. So then this system will go and look at the conditions in the market and put it in, and so that will determine the next rate. But the transaction systems do it almost only backward to today, because they only look what really happens. Now we do it into the future, which means also we have to have the whole environment of market conditions forecasted. That's how it is. But this could be an example, a variable annuity. So value date, that's where the money has been paid out, maybe in January. In February, maybe we have a first rate reset, but nothing happens. It's a complicated annuity here. So we just reset the rate. And in March, we pay first time a DAC. A DAC is interest and the principal payment, and we reset the rate again. In April, because it's a exotic annuity, it has only an interest payment, so that it has between two principal payments simple interest payments, and the rate reset. In May, again, interest plus principal, and the rate reset, only a rate reset, and here everything. So, but that's how we read it. Just look at the contract, what happens. We don't have to cramp our brain, nothing abstract, just like reality, actually. And that's a table of events here in an Excel sheet. Let's look at these. That's one contract, these together, interest rate swap. So the contract type, so the first line gives the contract type, so that's an interest rate swap here. And it says, what is that's the parent, contract type parent. That's the parent. So, and then what's the contract type child? In this case, it's a PAM. So we know we are dealing with PAM. The kind, it's a real event, because there are also notional events, etc. Here. Then there's an event date. So we always know when it happens. And the event kind. In this case, it's a repricing, interest payment, repricing, interest payment, etc. In euro, so it's a euro swap, here quantity 1, and here is the event value. You see there's a repricing, and this 0.057, that's an interest rate. So the repricing happens on 5.7% here. And so there is a payment of 41, here an interest payment, and this is then, so up to here the event is. Here there is already analytics. Here we get the net present value, and here we get the sensitivity, and here the liquidity. So these are the two branches I said. There's always this CES, or what we call in the book CS, for zero coupon equivalent sensitivity, because this is what it is. We treat everything like a zero coupon. Or the liquidity. So this is liquidity, this is the sensitivity. So we look at, for example, this event. This is an interest payment on the 30/6/2006. So we pay, minus is an outflow, so we pay this 41. And the sensitivity value is minus 41, and the liquidity, you see there's no difference. Yeah. And then there is an interest payment of 48, and that's the variable part. And you can see that. So we pay, and we receive. So we receive, we pay here, we receive here. And we see the liquidity effect is 48. It's the same number, like that, but the sensitivity effect is only 2.5. You see it's getting already a little bit more complicated, and you will understand very soon. Now maybe you know it now already. Somebody a guess why the sensitivity value is so much smaller than the liquidity value? Because it's after repricing, and only the spread gets a value. The rest, the non-spread part, has a value of 0. That just there's a little hint, but you will see that. We go through the examples. And so on. Here, for example, there's an interest repricing. It's an event value. It has neither liquidity nor a sensitivity effect. Then here we have again the payment, so that has a liquidity and a sensitivity effect, and this is maturity date event, but that's only of the variable part. You see it has a sensitivity effect, but this one has a sensitivity effect and a liquidity effect. And wait, there was one, I thought, oh no, that's the final maturity date here in this case. Sorry. No, that's the repricing, and that's the final maturity. You see here this one, that's the final maturity of this one. It has no sensitivity. That's the maturity of the variable part. It has no sensitivity anymore, and the liquidity. So it sounds a bit complicated, but you will figure it out. So once you think in contracts, you will see it will fall in place. It only looks now complicated because I jump in like that. So don't try to, no harm if you don't understand it at this moment, but you will understand it very quickly. So we start with the first example here. And these examples are the same examples as you find them in chapter 3. So in chapter 3, actually, we already talked about financial contract. So I picked them up again, and I show you now the numerical results of those contracts. So this corresponds to to figure 3.7. That's the most simple of contracts you can imagine. It has just two cash flows. It's a discount paper. Cash out, cash in, here. So we have on the 5th first a principal, and so we get first, and then we pay, so it's a liability. So we see that from this. And you see it has a liquidity effect and a cess effect equal, so there's no difference. And there's a discount included of 12.50 here. So which comes back then on the first 11th. So if we look at liquidity, we see we get 500 on the first 11th. That's a cash inflow, so most natural. And the cess is then what defines value. These are the 500 I get as a value then. But to get this, a net present value, for example, I will discount it yet. So this is only the raw input. That's the unmanipulated input, because it goes to the future, says there will be 500, which will be important for my value, and then I take that and discount it. We go to a fixed bond. That's an easy one as well. So we pay out on the 15th, 1,500, and we get it back. The other way around. We get on the 15th, 1,500, and we pay it back on the 15th, 03. So it's in 3 years. We pay it back. And we see also that here liquidity and cess is the same, because it's a fixed contract. So there is so the calculation for liquidity and value depends on the same information. But here you might find something interesting. You see we have regular intervals here. So every 6 months we pay interest. And we pay, what is 60 on 1,500? 2.5%? 1%, 4%. It's probably 4%. Huh? So, yeah, 4%, I would say. It's 15, 1%, yeah, 60. Yeah, because we pay twice interest. Huh? So it's a bond which bears 4% coupon, paid twice a year. So now you wonder, why is the number changing all the time? So you would say 30, 30, 30. So why? Somebody a clue here? Now this has to do with day-come method. This is most likely actual. Because the days, they shift. Huh? So when you expect the 30, 30, that's also possible, but then you had the 33, 60 day-come method in your mind. Which treats every month equal, independent of the number of days. So that's why we get these little fluctuations. But you will see over the years it will equal out, and you have the whole, the 6% exactly. So that's also quite a simple one. Now here is a RGM. RGM means regular amortizer. So it means it pays back principal in constant terms. And did we input one last Saturday? Yeah, we had one RGM last Saturday. We had. Today we will do that. Last we had an ANN, I think, an annuity. Okay. Yeah, so here we pay out in steps. You see it with this picture. So first 750 is paid. Let's say we pay for a construction, and we pay once more 750. And then we pay back, pay back, pay back. So that's, so you see this little ladder. And down here we see the interest payments. So first it's small and then it's big. What could be the reason? Because here it's on the principle of that, and here it's on the principle of that. So we have raised the principle twice. So of course you get higher interest payment, because before it was interest on 750, then it's interest on 1,500. So that's why it goes from 875 to 3750. And this time we have 60-day come method. That's why it's easier to calculate here. And then we pay principal back, and the interest going down to 1/3. And again, because it's a fixed rate instrument, liquidity and SAS is the same. So nothing magic there. Yeah? Yeah, at that time, yes, at that. And after we do all the manipulation, like discounting and so on. But that will change always. You know, you need to have that fixed part, and then it becomes easy. Yeah, it's always seen on that date. Yes. So here the special thing is a little bit that it has two payouts, which is normally not the case. And now here we have a variable bond. So now it becomes a little bit more complicated. So far everything was fixed. In a fixed world, life is simple. Also liquidity and value and all that, you can treat it on one set of information. You wouldn't need an event level if everything would be fixed. But the fixed rate bonds are more the exception. Now we have a lot again, but normally they will be again rare. So now here it's a variable rate bond. So we pay out 1,500. Yes. And we get 3 interest payments up to here. And they are 45 each. Here it seems to be 33.60. And then here on the 15.9, here at this point, that's here, we have a rate reset. So let's say the rate is set to 10%, just as a simple calculation. So that itself creates no liquidity, of course. That's only a calculation to calculate the interest. So no cash flow. Really, but you see here, why do we see a cash flow in CES? First of all, because it's only an artificial cash flow. It's only a calculation, so it's an event, really. So it's a repricing event. If you have a variable rate instrument, what drives the value? Let's say you have a 30-year bond, which reprices every 6 months. Do you think this instrument behaves value-wise and income-wise more like a 30-year bond or more like a 6-month bond? There's a 50% chance that you're right. No, but imagine, think on income. What drives income? It's the rate. And if that reprices every 6 months, so it's more the 6-month rate which drives your income. So it's actually a 6-month bond. From a value perspective. From a value perspective, it's a 6-month bond. And that gives you the idea what's the difference between CES and liquidity. By the way, this is also a simplification. As soon as you have a spread, it becomes a bit more complicated. But we keep it simple at this time. So you see, all the follow-up events after the resetting date, they have 0 CES. But the liquidity only comes then, because, and 75, that's the forward condition of you taking the 10%. So we have interest income of 75, that's the expected liquidity. Of course, that will be a cash flow. But beyond the repricing only, they expect a cash flow, because it still depends on the rate which is going to come. So it will fluctuate a little bit in reality around it. So now my question is, would you mind if I continue another 10 minutes and then after this you have only with Yanis? Is that fine? Yeah, okay? Okay, good. So let's finish this example. Huh? So the interesting case is here. So it's variable rate, and you have to be careful. But once you have this nice test and liquidity world, so everything will be fine. So this is the variable annuity. That becomes even more complicated. You know, you have here an annuity which is calculated to be, let's say, 10 years or whatever, but it reprices every now and then. So, and then the annuity has to be recalculated. So let's look at this example. So we pay out 700. So we give a mortgage, you say. So then the annuity is calculated. So it's 79. So that's the annuity calculation. Because given the term and circles and amount and interest rate, you know how much you're going to pay. That's the standard annuity calculation. That has to happen. And then from that, we know on the 16th, 9th, we are going to pay the 79.98. And so interest of that is 17.50. So the rest is principal. Okay. Then 6 months later, the same payment, there's no repricing, so that the payment still remains, but we have paid back already principal. So the interest goes down to 15.94, and we pay 64 principal back. That's the standard annuity calculation. And you see CES and liquidity is the same. But then we have rate reset, so that has no liquidity effect, but it has a CES effect, like before. Because at that point where the contract breaks. And so on. And here, because it's rate reset, so the annuity has to be recalculated because there's another interest rate. So the annuity is recalculated, and these are the events. It becomes a little bit more complicated, but just think in normal terms in how such an instrument works, and it's very simple. You get used to it very quickly. Yeah, a swap. So we had already a fixed leg and a variable leg of the PAM. And the swap is nothing else than two principal at maturity, one asset, one liability. So we take the same events like before, just sum them. So nothing magic here about the swap. So once we have understood the underlying events, so this is just a sum. And of course, we see that, for example, these two, there we have 1,500 inflow and 1,500 outflow, so they cancel out. So in a swap, there is no notional payment. There's a notional in the background, but there's no notional payment. So it's, but here, this is sensitive because this is the variable rate, so it's sensitive on the 15.9th, and that is sensitive only on the 15.3rd, 03. And there the risk transformation comes in. Hello. Yeah, yet one here, an FRA is also, FRA is an interesting instrument. So because you promise to pay a certain, or to do a certain loan, give or take, under certain condition. But what really flows is only the net present value on this time. So these cash flows, which are underlying here, you see they have no liquidity, these two, 980 and 1,000. This is the 980, this is the 1,000. It has only a sensitivity thing. And the real cash flow here has no sensitivity, but only liquidity, because you calculate this cash flow based on that cash flows using the forecasted or the forward rates then. So, okay. More complicated become things when we have behavior. So here we have a prepayment. And we said behavior functions, these are functions which are not known before. So the system cannot calculate it, basically, unless by shifting Monte Carlo and all that. That's the only way to do it. So that's why the liquidity is always clear, but here the sensitivity is not clear. Not automatically clear. The only way to do it is by shifting it and looking at it after the shift and before the shift and taking the difference and so on. But there's no analytical solution for it because the effect is not known before, because you define the effect. It's a statistical nature impact. That is the impact of behavior. Yeah, just as a last one, so what do we do? The first analysis now which we get out of that is the liquidity gap. The liquidity gap is nothing else at looking at my balance sheet or whatever portfolio and see how much inflow, outflow I get from this portfolio over time. So I need time buckets, that's the first thing. And I calculate what I take from all the examples which we had, I go to this column. And just look at the date here, look at the time bucket, when does it fit into which time bucket? That's all you do. So you get that, and if you go through the examples, you just sum up all the examples which were there. You get that in the first half year we have a net inflow of 94. In the second half year we have a net outflow of 404, and so on. And this is cumulative gap. This is nothing else than summing this up over time. This is just the accumulated sum of that. And what you get is something like this. And this is what the treasurer is really looking at. Now here we have half-yearly buckets. The treasurer, of course, would go in much narrower bands. He would go in daily buckets for 30 days. So he knows from the existing business, every day, what do I expect as inflow and outflow? Inflow and outflow. And especially interested is he in the cumulative gap, because the first dangerous point is if that turns negative. Because what does this reflect? That means from the existing position, I have more outflow than inflow. In normal time, that's not the problem. But if the market stops, that's basically the survival period. So that's the period you can survive on your own. And actually, liquidity risk management has a lot to do with that, calculating that survival period. I think, how much is it? 3 months is the minimum? Oh, now they shortened it. Okay, so it's quite risky. So at least you have to survive 2 weeks, but it's not easy for every bank. Depends on your position. So that means the banks have to be able to survive 2 weeks without any external intervention. Just by drawing down, getting in what you have from your natural flow. Okay, so much to liquidity analysis. So let's make a break now. And Jan is, so you can, when should we meet again? 9:15, anyway, it goes to 9:15, huh? Is that, oh yeah. Let's say 20 past.